All right, let's try this again, see if this works for everybody. We are going to look at 5.2, integration involving natural logs, worksheet B. This one focuses in on the degree being higher in the numerator or the same as the denominator. So numerator's degree is higher or the same as the denominator. So that should be the hint that we need to use long division. So that's what we're going to do. So first one here, we're going to set it up and say, okay, x plus 1, and then we got the x squared minus 3x plus 2. So what multiplied by x gets me x squared? That's going to be x. Multiply that on down. Subtract that. We're going to have negative 4x plus 2. So then negative 4 times x gets me the negative 4x. So this will be minus 4. So multiply that on down. And this will end up being 6 down here. As soon as this has a degree that is less than this, so this has a degree of 0, that has a degree of 1, that's going to be quote unquote our remainder. Okay? So I get 6 over x plus 1 up top. So this integral is actually equivalent to the integral of x minus 4 dx plus the integral of 6 over x plus 1 dx. I like to separate it like that just in case I need to use substitution. Typically, this is just going to be a power rule scenario. So if we do that, this is nice because this use substitution is just going to have a natural log of x plus 1. It's the derivative is going to be dx. So this is just going to be add 1, divide by the new, add 1, and then this is going to be plus 6 natural log of x plus 1 plus c. And that would be the final answer. Okay. Let's see here. That's what I got there. All right, cool. Second one. Let's go ahead and set up our, notice, degree higher in the numerator than the denominator. So this is going to be a long division. So 2x squared plus 7x minus 3. So x times 2x gets me 2x squared. So this will end up being 2x squared minus 4x down here. So we take the opposite signs because we're going to subtract that. So this will end up being 11x minus 3. So 11 times x gets me 11x. So this will be plus 11. So when we multiply it out, it'll be 11x minus 22, which will make that a plus 22. So we're going to have a remainder of 19 over the x minus 2. So I'm going to go ahead and rewrite this as the integral of 2x plus 11 dx plus the integral of 19 over x minus 2 dx. Once I get here, it's pretty straightforward, especially if this is just a linear representation with the degree or a derivative of 1. So this is going to be add 1 divided by the new. So this is going to be x squared plus 11x plus 19 natural log of x minus 2 plus c. Okay. Third one down. Okay, we're going to go ahead and put the x minus 3 out here. And remember, if you are missing a term with an exponent, like the x term here, we got to put in 0x. So this is going to be x cubed minus 3x squared plus 0x plus 5. So x times x squared gets me x cubed. So this will be x cubed minus 3x squared. So that'll actually become a plus x squared. So now I'm going to have 0x plus 5. So this is really going to be the remainder then, the 5, because it's a degree less than the x. So this is going to be plus 5 over x minus 3. So that'll end up giving us the integral of x squared dx plus the integral of 5 over x minus 3 dx. Well, the 5 is just a scalar over here. So this is just going to be the power rule. So this will be x cubed over 3 plus 5 natural log of x minus 3 plus c. All right. Let's just double check and make sure those are the answers I got first time around. Yep. And yep. Sweet. It's good when you do it well. All right. So going on to the last one on this page. Okay. We got the x plus 5 here. Let me move this real quick. Hold on. Give me a little more space. Like it. There we go. So we got the x plus 5 there. And we got x cubed plus 0x squared. We're missing that term right there. Minus 6x minus 20. Okay, so x times x squared gets me x cubed. So this will be x cubed plus 5x squared. Subtract that second row. So this will be negative 5x squared minus 6x, because you just pull that down. So then multiply by negative 5x to get the negative 5x squared. So this will be negative 5x squared minus 25x, but we're going to have to subtract that row. So this will be 19x minus 20. So add the 19 here, because 19 times x is the 19x. So this will be 19x plus 95, which really ends up becoming minus 95. So you get negative 115 there. So that's going to be my remainder. Okay. And once we have that remainder, okay, we can go ahead and rewrite this as the integral. And this is going to be my integrand. And then I'll make another integral where this is, another integral if you want. You don't have to do that. You don't have to separate them into two. I just do it because it's easier on the eyes. So this is going to be x squared minus 5x plus 19 with respect to x minus the integral of 115 dx over x plus 5. This is straight power rule. This degree of 1, so your derivative, since the scalar here coefficient is 1, is just going to be dx. So I could pull that negative 115 on the outside, and maybe it'll be a little easier to notice that this is just going to be the natural log of x plus 5. So once all said and done, this is going to be x cubed over 3 minus 5 halves x squared plus 19x minus 115 natural log of the absolute value of x plus 5 plus c. Okay. Second page. Okay. Same scenario here. All right. We're going to let x squared plus 2 be on the outside, and then x to the fourth. And then we got quite a few that we have to plug in. So 0x cubed plus 0x squared plus x minus 4. So x squared times x squared gets me x to the fourth. And so then this is going to be plus 2x squared. But I'm going to subtract these. So this will be negative 2x squared plus x. So I multiply by negative 2 to get me the negative 2x squared. And that'll be minus 4. But in reality, I'm going to be adding that. So I'm going to be left with x there. So that's going to be my remainder, plus x over x squared plus 2. So this scenario is going to be rewritten, or this integral is going to be rewritten as x squared minus 2 dx plus the integral of x dx all over x squared plus 2. This one is straight power rule. This one is going to be a little bit of a u substitution. If I let u equal x squared plus 2, then du equals 2x dx. But I want to replace x dx, so I'm going to multiply both sides by 1/2. So in reality, it's just going to be 1/2 natural log of u. So some of you are getting the hang of this. You're just going to be able to, write the natural log. Once you identify that, you can kind of save some time. And here I am rambling on, so I'm not really saving time. X cubed, add 1, divide by the new. This is x to the 0, so add 1 is 1, so that's the negative 2x. And then this is just going to be a 1/2 integral du over u, so that's going to be plus 1/2 natural log of u, which was x squared plus 2 plus c. Boom. Okay, second one on this page. Still got the x squared plus 3 in the bottom there. And then we got x cubed minus 3x squared plus 4x minus 9. So x squared times what gets me x cubed? That's just an x. So it's going to be x cubed plus 3x. That's interesting. So When we multiply it out, we're going to get subtract. This is going to be negative 3x squared plus 1x. And I got a minus 9 there. Sorry. So then multiply this by negative 3. So then I get negative 3x squared minus 9, but in reality that's going to become a plus 9. So then I'm left with just x here. So that's going to be my remainder, x over x squared plus 3. So it has a similar feel to the previous problem where we're going to have a little bit of a u substitution to work with. So this ends up being the same as the integral of x minus 3 in the integrand with respect to x plus another integral of x dx all over x squared plus 3. So here my u substitution, u equals x squared plus 3. du equals 2x dx. Multiply both sides by 1/2. So then when we piece this thing together, this is the power rule. This is going to be add 1 divided by the new x squared over 2 minus 3x. And then this is just going to be 1/2 du over u, which is the natural log. So plus 1/2 natural log of u, which is the x squared plus 3 plus c. For the next one, looks like long division is kind of out of the picture here. You can actually look at this a couple of different ways. It really doesn't matter, but you just got to pair it up with your multiple choice question. To me, I'm going to look at this and be like, hey, let's just use our power rule. Let's bring that 3 on the outside. This right here is equivalent to the integral of dx over x ln x, but this 3 can be pulled out in front. So I'm going to make that a scalar of 1/3. So when I do that, I'm going to say, all right, well, let's let u equal natural log of x. And why would I do that? Well, remember, something's got to be u, and then everything else needs to be part of the derivative process. So when I let u equal ln of x, du equals dx over x. So when I try and replace this whole scenario right here, the dx over x is going to be replaced with du, and this right here is going to be replaced with u. So when I write this, it's going to be 1/3 integral of du over u, which is equivalent to 1/3 natural log, as the lights go out. It's going to be equivalent to 1/3 natural log of u, which was the natural log of x, plus c. Pretty cool. Okay, this scenario right here, this is just trying to show you how you can do a u substitution if you really need to with a definite integral. Remember, we're going to have to reevaluate or redefine our boundaries. So in this instance, I'm going to let u equal 2x plus 3. du equals 2 dx, but I want to replace 1 dx. So I'm going to multiply both sides by 1/2. So when we rewrite this, I'm going to get 1/2 integral of du over u. However, these boundaries need to be rewritten. So when I plug in -1, I get -2 plus 3, which is 1. And when I plug in 1, I get 5. So from there on, I do not care about this problem anymore. This is my new problem. So this is going to be equal to 1/2 natural log of u from 1 to 5. So this will be equal to 1/2 natural log of 5 minus 1/2 natural log of 1. But we know what natural log of 1 is. It's 0. So then this is just going to be natural log of the square root of 5, or you could, just make sure that you know what the multiple choice equivalency is. Okay? Hopefully that helped. And we will move on tomorrow to exponential